Hello and welcome to the Tech for Climate podcast. I'm Guillaume, your host, and each week I'm fortunate to share with you stories from climate tech founders, investors, and corporations sharing their unique insights into this fast-moving industry. Eventually, like me, you will learn, discover, and get inspired by those unique men and women who are contributing to the fight against climate change, and I hope it will help you to take a step in this formidable movement. So before we start, I just want to share a few words about us, as this podcast is just the tip of the iceberg of what we do at Startup Basecamp to support the climate tech movement. Our mission is to accelerate capital deployment towards climate tech founders, allowing them to focus on scaling their solutions. How do we do that? Every day, we help founders access to resources and connection and gain the visibility they need to expand their growth. We do this in a number of ways with a membership platform, a Slack group with a growing number of founders, investors, and experts from around the world. And recently, we went one step further with the matching services to connect founders with top climate tech investors. Keep in mind that we are able to do all of this thanks to the support of our listeners and our members. So please like and subscribe, share one episode with a friend, join a community, and if you haven't already done so, make a small donation to support our work. It really means the world to us. And now, enjoy the show! Hi everyone, in this new episode of our Founder Series, I had an insightful discussion with Anas Al Kassas, founder and CEO of Inovues, a startup that makes buildings smarter and greener for a sustainable future by integrating the latest energy-saving and smart glass technologies into existing windows and facades without replacing the existing system. Anas, who is an architect and facade engineer, will share with us his passion for dynamic and smart facade systems and how his journey led him to work on mega-scale projects in Dubai before pursuing his master's in architecture in the US. Inspired by his father's entrepreneurial spirit, Anas embraced risk-taking and innovation to address the energy efficiency problems in older buildings by founding Inovues. In this episode, you will have an insider's perspective, deepening your understanding of the construction industry and the glass sector in the US. We will cover together the technologies that are being developed, and we will perform a zoom at the current and upcoming climate regulations and incentives tailwind impacting the glass industry, as well as covering the strategies penetrating this billion-dollar market. Finally, we will hear how you can get involved with Inovues' mission to decarbonize the built environment. So in the second part of the show, Anas discussed the importance of milestones-based approach while fundraising. Anas also shares how the flexibility from working from home has helped him achieve a work-life balance. Anas, welcome to the show. Hi, Anas. Welcome to the Tech for Climate podcast. I'm super happy to have you here with us today. I believe it's going to be a great opportunity to hear your story and understand this exciting adventure that you are on with Inovues or Inovues, depending of your French accent or English accent, I would say, but which is re-energizing building facades and transform their windows into smart, energy-efficient, renewable systems without replacement or disruption. So welcome to the show.
Thank you, Guillaume. Pleasure to be here. Really excited for talking with you.
So before we start, is a tradition on the show. Can you give us a 30-second introduction about Inovues?
Sure. So Inovues re-energizes building facades through our window retrofit innovations. Basically, we make buildings smarter, greener, and healthier for a better and sustainable future. We integrate some of the latest energy-saving and smart glass technologies into existing windows and facades without replacing the existing systems at all. So we cut costs of window upgrades and save building owners up to 40% on energy consumption and carbon emissions, and make buildings more, thermally and acoustically comfortable for the occupants.
So let's start from the top. In this show, we like to first focus on the speaker as a human. So can you share maybe with us like your personal story, background? I mean, what are you passionate about? What do you love to do besides building interviews? I mean, what makes you feel inspired or your best self? As I always ask, like, who is Anas?
Sure. So I'm an architect and a facade engineer. That's my background. I studied architecture in Damascus, Syria, and graduated. I had passion for dynamic facade systems and smart facade systems early on. My first serious attempt was my bachelor's degree project, which was kind of a little bit complicated. It was a retrofit system for an existing building also that can change into 108 positions. It ended up winning an international award, and that got me into the facade engineering kind of industry or sector. Instead of going through the traditional route of working for an architectural firm, I went and worked for a facade fabricator and window fabricator. There I learned basically the ins and outs and how these kind of bespoke curtain wall systems and glass wall systems are designed, engineered, fabricated, and tested. That was in Dubai when I worked there for like 4 years on some of the mega scale projects in the area. After that, I went to the US, did my master's in architecture, went back to the architectural school, and started working at the kind of intersection between architecture and facade engineering. I was kind of the person responsible for the facade and the building envelope on some big projects in the US and internationally. So that's my background. Very interested in basically innovative facade systems or building envelope systems. I look at the building envelope as one of the main components in a building because that's kind of the envelope that regulates and protects and form the building basically. So there's a lot of innovation can happen there, a lot of creativity in the building envelope. That's why I love what I do. That said, when I started learning and doing interviews, I came across the energy efficiency problem. Architects a lot of time focus on new buildings and they design them to the highest standards, to the current building code. We do not think much about the existing buildings, like the buildings that were built 20 years ago, 30 years ago, even 100 years ago. What's going on with them? How can we bring them up to current standards, make them more energy efficient? So when I started interviews, I started looking at basically how can we integrate the latest technologies, smart glass technologies, smart window technologies into existing building envelopes without having to replace them. And that's when I started seeing that there is a big energy efficiency problem with the windows, and that's how I kind of shifted focus towards this problem.
So, sharing a little bit like your journey as you just did, if you look back at it and you take maybe like what is the one or two piece of experience in a way that it gave you an edge to start a company? I mean, what did you learn on that journey? Maybe like one of the examples where you look back and you say, yeah, this is really helpful on this journey of like launching a company because it's so different than working for a company.
Yeah, I mean, I'm a first-time founder. Haven't been in business much in a professional way, other than being, in a capacity of an architect and a facade engineer. However, if I want to reflect back on my upbringing, I can say that my father was a true entrepreneur. So he started several companies and businesses and kind of developing new products and technologies. So I was exposed to that kind of risk-taking mentality and approach to business. And I can say that helped me a lot because, when you're starting a company, there's a lot of risk. For example, I quit my job in Boston, moved to Houston to start this. And there's a number of steps that it's not for everyone. And I can say that part of my life, I think, influenced or helped me be a little bit more risk taker and open to innovating and trying new things, even if that means there is uncertainty and potential risk down the road that it could not work. So.
So before we start and we look a little bit more at the macro approach of the built environment per se, you mentioned that during this journey, as well as an architect, you started to look at like the problem of energy efficiency, and that gave you, in a way, the path to what you guys do with Innovue today. But related to this more like at large, this climate tech industry, what was your, in a way, aha moment or motivation to really say, okay, let's jump into that and let's try to focus on that problems with this background and this knowledge that I have into the space?
Yeah, I mean, the first aha moment for me was when really I saw a thermal image showing the skyline of New York City. And that was striking because it was, anyone without an engineering degree, without any experience in building envelopes or, performance or anything, would be able to see how much energy loss is happening through these buildings. I mean, buildings are energy hogs. If you look at basically right now, a chart of who's consuming more energy, emitting more carbon, and you look at the building industry or the building sector, it's the biggest. It's up to 40%. It's more than transportation. A lot of people and a lot of research has been done sometimes, and they don't factor every single aspect of the building industry. You have existing buildings, you have new buildings, and between both of these sectors or subsectors, you have up to 40%. So that's more than industry, more than transportation. And now you look at the building sector or buildings, and you see that you have heating and cooling. Obviously, that's the kind of the highest consuming aspect of building operation. But what's contributing to that consumption is really the building envelope, because if you have an efficient building envelope, you don't need a lot of energy to cool and heat the building or the space to keep it comfortable. And that's why that thermal image was very striking, because you can really see how many buildings are energy efficient, and that the majority of buildings are really inefficient and leaking a lot of energy through these glass facades and windows. So that was really a big aha moment that got me into trying to learn more and reading more and looking into statistics and research about the topic, about energy efficiency for existing buildings. What are the performance criteria was at the time of building these buildings in different kind of vintages, different time frames. So that was a big moment. Yeah. You're muted, Guillaume.
Thank you. I was
Needs to
like,
happen
I
on
receive a
everything.
pop-up. I was like, uh-oh. Okay. So now that, I mean, that we know a little bit more about like this overall contribution of the built environment in itself, in terms of like contribution, in terms of greenhouse gases and like this impact on the climate change that it can have. I mean, if you step back a little bit, like, where are we at today in terms of like making this all built environment more energy efficient and in a way decrease the impact? And how far can we still go? I mean, if you had like a goal in itself, what is the existing status there?
So I remember reading some reports from the Department of Energy here in the US showing that basically existing buildings needs to become about 40% more energy efficient to be able for the existing building stock to reach the level that is needed to get the built environment to net zero. So if you think about getting every existing building built before 2000, let's say 40% more energy efficient, that means you are looking at deep energy retrofit measures, not just like low-hanging fruits, kind of measures. So that absolutely requires addressing the building envelope. Now, there's a lot of work happened or is being done right now around retrofitting existing buildings. There's a lot of initiatives. If you look in the past, over the past few years, uh, there's grants offered to develop such technologies that are scalable, can be integrated into many building types and vintages, and can be easily installed, low cost. And there's a lot of innovation on heating and cooling, but we're now kind of starting to see things related to the building envelope as well. Historically, anything related to windows, facades is very expensive. So it doesn't pencil out as an energy efficiency retrofit. It ends up being, resulting in a very long payback period, sometimes over 100 years. So you building owners just, they're wired not to think about facades or windows. So that's the thing that happens only if it breaks. So that's what we're trying to change now to make that happen. So that's where the kind of facade retrofit, window retrofit kind of new technologies are coming into play. So
now that we frame a bit better the context, and as we discussed together prior to the interview, let's double click on one part to decrease the impact of the built environment, looking at the windows and the envelope in itself. So maybe if you could start by giving to the audience your overview of the glass window sector in the US. I mean, today, I mean, which technology is in place, when it's been developed, and which change is required to go up to speed there?
sure. So there's not a lot of statistic documenting exactly what is the makeup of the windows in each building here in the US. Unfortunately, there's been some research done in certain geographic areas, some surveys. So, and based on that, the Department of Energy estimates that basically about 40% of the existing building stock have single pane windows. When we talk single pane windows, that means like a single sheet of glass, single layer of glass. Now, there is something called double pane windows for those that are not familiar with windows. So you have single pane, you have double panes. That's kind of the standard terms. Double pane means you have two sheets of glass with a thermal air gap, or a thermal gap between the two panes that gives you sort of like that insulating value, like a thermos, for example. So double pane windows start being introduced into the market around, let's say, the 60s, 70s. And that's where they, 70s and 80s started to get like that adoption with low emissivity coatings and energy efficiency coatings. So you have that big chunk of the building stock have single pane, about 40%. Now the remaining 70%, half of them have the early version of those double pane windows, very energy inefficient, reaching the end of life. So you're talking about, in total, 70% of the existing buildings today, all existing buildings today, still have obsolete windows or energy inefficient windows. That needs to be upgraded. Now, in terms of square footage, globally, we're talking several billion square feet. That's a big number. There are estimates that quantify single pane windows at almost 200 plus billion square feet. So that's a big problem globally. Now, in order for that to be upgraded, you have now technologies. If you look at the current state of the art, you have at the highest end, you have vacuum insulated glass. So two panes of glass, but instead of, let's say, air in between, or certain gases like argon or krypton that has a little bit lower thermal transfer value than air, is you have this vacuum. So basically you're having 10 times the insulating value of a single pane. That's the current state of the art. And in between, you have a lot of technologies. You have even smart glass technologies that change their tint automatically or up on demand to reduce the solar heat gain, make the space more comfortable. So there's a wide range of technologies that are available today that are only accessible primarily for new construction, or if you have to replace your entire facades and windows. So that's where we are. And ideally, you want to get, like, you have building standards and passive house standards where you need to be at triple pane performance. So there's something called an insulating value called R value. A single pane window has an R1. A vacuum insulated glass has R10 plus. And then building codes today are around R3 up. And ideally certain green building standards are R5 or up, like passive house, for example. So really, to be able to certify these buildings to become green buildings, or if you want to upgrade them to get to either a little bit more energy efficient, electrify the building, decarbonize the building, you need to be at that level, and you need to upgrade them. You cannot do it with the R1 or R2. So that's why retrofits are needed, really, for these kind of systems.
So maybe if you could tell us a bit more about this regulatory framework, because I believe it's playing a massive push into that market. So what are the regulations currently in place, and what are the one missing according to you, and maybe how is the IRA impacting the market in the US per se?
Yeah, I mean, if you look today, there is the building code. That's what's kind of guiding the building industry, but that's focused mostly on new construction. When it comes to existing buildings, it's applicable when you're doing a major renovation, for example, or certain big changes in the building. That's when it gets triggered. Now, there is now energy efficiency or an energy code for buildings that require certain standards to be met. You have the International Building Code. Basically, that's what's adopted. You have multiple versions. Every couple of years it gets updated, and then certain cities starts to adopt the next version over the next few years. So you have different building codes in different states. You have different requirements. Some states are more stringent than others and mandating certain buildings to be at a certain level. So if you look, for example, now at New York City, they're not only relying on the International Building Code, but they're also mandating to cap fossil fuel emissions and energy consumption, basically, in existing buildings to be at a certain level. And if you don't meet that performance criteria, then you're facing steep fines. So that's Local Law 97, for example, in New York City. That's complementing or creating this great movement to push building owners to upgrade their performance beyond just the building code. However, that's not the case in every city. So there are other cities like Boston. They have their own version of Local Law 97, for example. Burdo, I believe it's called. And then there is, in certain areas like California, mandating to be at net zero by 2030, and then starting with government buildings, mandating the retrofits. So yeah, these kind of different laws and regulations that are pushing this energy efficiency movement to gain more traction and build momentum and get it into the market. And on the other hand, you have incentives offered. So you mentioned the IRA, but before the IRA, you have the energy utilities. The energy utilities are offering really interesting and significant cash incentives for building owners to upgrade and reduce the energy consumption, make their buildings more energy efficient. And that can be, just to give you an example, in New York City, for example, Con Edison is offering up to 30% of the total project cost, up to $1 million, to help you upgrade your building. So just think about that. That could really accelerate adoption of a lot of energy retrofit technologies. Same thing in Boston. We have now a project where we secured about 20% from Eversource and National Grid for window retrofits. Now, these kind of incentives, they're not only for a specific product or for a specific technology or building component. It's for anything mostly. And even if you're building a new technology, you can apply and say, hey, my product or my system or my technology can save this amount. They do some sort of validation on that, energy modeling before and after, look at the technology, and if it's accepted, then you'll become qualified to apply for these incentive programs. So now we talked about regulation or mandating retrofits with fines. You have the cash incentives from utilities, and then you basically have the Inflation Reduction Act, which is offering on a federal level cash incentives through tax deductions or tax credits. So you have the ITC, basically the investment tax credit, offering up to 30% of the total cost of implementing some smart glass technologies into the building, like dynamic glass, for example. Even if it's a retrofit, so even if it's integrated with our system and then you install it on an existing building, you can qualify for that. And on the other hand, you have the 179D tax deduction, giving you 69 cents for envelope retrofit specifically, and up to $5 in general per square foot of building area for energy efficiency retrofits if you upgrade beyond 10% or 25% in terms of performance compared to your previous year performance. So you factor all of that together, and then you see this big incentives that is driving now or pushing this kind of energy efficiency movement, and making it more attractive to building owners to adopt, and making it a good time for them to do it. So and I believe in Europe is the same case. There's a lot of regulation and incentives offered. You have higher energy prices in certain areas than in the US, so there's the payback period is much faster to implement these energy retrofit technologies. So perfect timing now, I can say. So
So maybe last question on that sense. So we understand like the push on the regulation part, on the incentivization, and like that you can get as well. On the other side, and you've just mentioned that like versus Europe is slightly different because of the price of energy. But what is the stake of I would say the current price of energy to accelerate and change the building owner to basically decrease their energy bills at the end? Is that something that really goes into consideration for them, or is still like the change in terms of that you get is so minor that is not part of their I would say plan or incentive to adopt a better like energy efficient windows?
no, that's a great point. So in our cost saving or cost benefit analysis, we incorporate a 3% escalation rate for energy prices. And that's been sort of like on average. However, if you look at last year, like again in New York City, there's been, I believe, an increase in energy rates by 20 or 30%. So like a big jump, not 3%, and that's just a single year. So the estimates with 3% escalation rate, if you look at that with or without, it really impacts your energy savings, ROI, payback period. So especially when you're looking now into electrifying buildings and moving them onto the grid, there's going to be a huge demand for electricity. Certain cities, the grid cannot handle that demand if all buildings transition to electric all of a sudden. So that could create some sort of uncertainty around energy prices for the future. And we even had certain clients when we submitted our cost benefit analysis, they asked us, you need to put like 4% or 5% escalation rate. That's the case. That's what they factor into their models and calculations. So it's a big point, and it's something that needs to be factored if you're looking long term, especially for technologies that last like 10, 20 years. So you want to factor that into the payback analysis and the ROI analysis.
Any other point that you would like to add for this more like macro environment view in this discussion?
I think we covered a good part of it. I don't have anything on my mind now to add, but maybe later during the discussion.
Okay, so let's go deeper into Inovues. Can you remind us a little bit like the story behind it, and which gap did you guys identify initially that led to the current version of Innovue, and in a way, why did Innovue have to exist?
Yeah. So the idea was, in very few words, is we want to upgrade the existing facades and windows without replacing them, because replacement, throwing away these existing components, is just not cost efficient. It's not environmentally friendly. It's it's unsustainable in general on the long term and short term, because you have these materials. Not all of them reach the end of life. You have metal, you have glass. That glass, for example, can last 1,000 years. So you have certain sealants, gaskets, things like that deteriorate fast at the beginning, and they reach the end of life after 5 years, 10 years, or 15 years. But you can kind of reuse and upcycle the rest of the facade components or window components. If you throw them away, you put them into landfills, and then you have to build new from scratch. Again, that's unsustainable in terms of materials used, and materials thrown into landfills. So what we wanted to do is keep what's existing, add to it, and bring it up to current standards, or the highest, basically performance levels, and enable it to integrate these kind of cutting edge technologies available today. So that's how I started. I started doing kind of research to see if there are anything in the market like this that enables this kind of retrofit approach. And there was not. Every kind of solution required having to replace the glass, or major parts of the facade system, sometimes even the entire facade and window system. So that got me into trying to think of developing a technology that can bolt on to existing windows, is adaptable, that works with all the different kinds of window systems and facade systems, and at the same time is agnostic to the glass technologies and able to incorporate or adopt anything that is available today or going to be available in the future, and make the facades upgradable, renewable. So that's kind of the notion, or the kind of the crux of why Inovues exists. That took several years to kind of figure out and develop, a long R&D journey to make it work, and develop certain iterations of our flagship technology, and then do R&D testing, do prototype testing, and then mock-ups, and then pilots on actual buildings, and experience the performance over winter, summer, harsh environmental conditions, and see how it works, and reiterate and improve. So that's kind of the story behind the development that happened at the beginning, be it for Inovues technology.
So maybe you can tell the audience a little bit about like in itself the product. If you could walk us through like the process. I mean, how does it work? Let's say I'm a developer or I'm building owner and I need to improve my Windows efficiency. How does it work? How long does it take from start to finish? Which return can I expect in general, and in which timeline? I mean, if you could help us to visualize the whole process and understand in a way your secret sauce.
Yeah. So our flagship technology is called insulating glass retrofit, or IGR, and it's attached on the existing glass. So we have kind of two main parts. We have a spacer frame that uses our proprietary aluminum extrusions. They're machined using high precision CNC equipment, and has a pre-applied structural glazing material. Those spacer frames gets attached directly on the glass, and then you apply a little bit of pressure to activate that structural glazing material, form them as a frame using 3D printed hand guiding tools. And then after that, you have the actual panel, or the window, the added window. It's a glass panel with another subframe, and a number of other materials, desiccant, secondary sealants, primary sealants. Now, this second part mates with the first part, interconnects and interlocks using small movements on 3 axes without using any fasteners or rivets or bolts or anything. And then at the end, once it's installed, we apply a special vapor seal around the entire perimeter, basically creating a hermetically sealed insulating gap that performs like a factory-made insulating glass unit. So that's kind of the notion, that you're turning single pane windows into double pane, or double pane into triple pane in place without having to replace, remove, drill, or alter any existing components. We can do that very fast because majority of the product is prefabricated. The product is super lightweight because we're relying on the existing facades and windows, so it uses 70% less material than a full replacement, and the installation takes minutes basically to install, 10-20 minutes depending on the window location, window size, where it's located. So that's kind of our flagship technology. It's adaptable, works on the exterior. You could be sleeping behind the window. The installation happens on the exterior without any disruption, or it can be done on the interior behind the window. It sits behind the glass. So it's that's basically how it works. Now, from the building owner's perspective, in terms of a time frame, timeline, let's say you have a 10-story building, and that could take a few months to do our install, sometimes a few weeks, depending on how many windows there are. If you were to replace the facades and windows and go through the entire process of, from start of, hiring consultants and architects and going through the permitting process all the way to execution, GC and subcontractors, demolish the existing facades, vacate the spaces, take out your tenants, lose rent or income, all the way to potentially finishing the installation. We looked at several projects and did comparison. That could take a couple of years to do from start to finish. So that's why there's like extremely high costs, and we were able to cut costs by up to 90%, because you almost eliminate all of those middle points and all of those kind of steps. There's no need to vacate, no disruption to the operations of the building. It can be on the outside, installing very fast, 20 minutes per window versus several hours per window. So that gives them a much faster lead time to start realizing these energy savings and comply with the regulations, and have a cost-effective retrofit versus a full replacement. So that's kind of the idea. We help the building owner from start to finish. We provide energy analysis before and after, showing them the performance, the savings, the expectations, and then even apply for the incentives for them on their behalf to the energy utilities. We go out, measure a few windows. We don't need to measure every single window because our system is adaptable and takes into consideration the irregularities and squareness of certain windows. And then we fabricate, we ship, we install using local, qualified, and trained installers. So it's a very smooth one-stop shop kind of approach to these retrofits, so the building owners don't have to worry about who's doing the install, who's offering this warranty, who's doing this, who's doing that. We take care and handle basically everything, and outsource a lot of the kind of parts of that process to partners that are local, where the project is located.
So maybe tell us a bit more about like this whole, I would say, logistic approach that you have. So basically, we understand you go, you see the building, you discuss with the owner or the developer. You guys take measurement and everything, give them some report in terms of energy efficiency. Then you go to production. How does it work? Where do you produce? Where do you source your glasses as well? Do you have like preferred partners? How do you give a certain level of like degrees of certainty or warranty on your product? How long can it last? And then how do you train those those installers? Like, how do you manage all of that together?
Sure. Starting with kind of what's produced. So right now we fabricate our products in Houston at our partner's fabrication facility, Momentum Glass, and we have our product specialist, QC specialist, kind of overseeing that process to make sure everything is being built to our standards. And basically we source the glass locally. So what we try to do is, basically get all the materials in the US locally. And even if we, right now, for example, we have potential projects in Canada, we're talking about sourcing the glass locally in Canada, at least doing the assembly there until we have a manufacturing partner who can, fabricate and assemble everything locally. That's the more sustainable approach, the more cost-effective approach. Instead of having to ship very heavy materials from overseas or different locations. The same thing if we go to Europe with Saint-Gobain, let's say in Poland or France, we'll be sourcing the materials locally. So that's the product fabricated in Houston. We have certain components that are proprietary. These can be shipped as a kit of part, like an IKEA product, for example, and then glass only can be sourced locally, or all the materials and the fabrication, depending on the capabilities of our fabrication partner, what kind of equipment they have, what kind of skills and expertise they have. We can basically outsource everything, license the technology, or we can sell them the proprietary components and they do the assembly and then they act as a reseller. If they have installation capabilities, they can also do the installation. Now, that brings me to installers. So installers, we have a growing network of local qualified installers right now in the US, our main market. And what happens is that at the beginning, for example, we're going to a new geographic location or a new market, let's say New York City or Boston or Seattle. So we connect with kind of the top glaziers there, and we kind of have a training period at the beginning where they get to see the prototypes, and then we do mock-ups. They install them, they get to see how long it takes, how it works, and then we do sometimes even pilots. And then from that point on, we work with them on any future projects in that city or in that market. And as we go and expand, we add more qualified kind of installers. These installers ends up once they become comfortable with the technology, they can become the kind of, again, as a reseller. We sell them the product and they sell it to building owners. They manage the installation and the warranty service. So on the warranty side, so the standard warranty for windows in the market is basically 10 years, limited material warranty. That's what we offer. We also include a 1-year labor warranty, so that if there is any kind of workmanship issues during installation, that will be covered for the first year, no questions asked, no cost to the building owner, to help de-risk this kind of new technology from their perspective and not enable them to feel more comfortable adopting this solution. But the product, technically, it's designed to last the lifetime of the building because, again, it's upgradable. So you can, let's say, the desiccant material reaches the end of life after 10, 20 years. You don't have to throw away the double glazed unit, the IGU or the insulating glass unit. You can basically just reverse the movement, cut the perimeter vapor seal, reverse the movement, take out the panel, just replace the desiccant material, put it back in, seal it, and then you have another 20 years of performance without having to throw the retrofit or even the existing facade system. So you have this kind of upgradability that makes facades more sustainable, and it's a low carbon solution because you're maintaining these kind of materials and reusing them every 10, 15 years or 20 years, depending on the cycle.
What are the existing limitations with your product and in terms of type of building that you guys are experiencing today, and what's next on that sense? Like, do you Tell us a bit more. I mean, is it really suitable for every type of buildings? I mean, we understand those large glass window type of buildings, or like brick windows, and I mean, office buildings, I would say, maybe more. Tell us a bit more about like where's your area today and the limitation that you have, and the one that you are looking at after this step.
Yeah, so we have developed several products and systems now that kind of complement each other. So this way, obviously, there is no single technology that works on every single building, every single window type. However, so our flagship technology, the IGR system, I would say works on 80% of buildings. And the other 20%, so we have another product called the SWR, secondary window retrofits. It's breathable and complement this first one. So these two systems, between them, we can really cover, I want to say 90% plus of all buildings. That said, you have certain situations where it might not make sense for certain buildings to do it. Not because our system doesn't work, it's just sometimes it doesn't make sense from a financial perspective unless they absolutely have, there's significant incentives available and that location and energy prices will justify these kind of retrofits, and especially if they have expectations with like 5 years payback or under. So that's where sometimes, if you have very few windows, you have all concrete building or stone, 1900 type building, like, pre-war. And no matter how energy efficient the windows become, you'll still improving maybe getting 5% energy savings on your overall bill. So sometimes building owners say, well, this is not a good fit for us. In other cases, you have some historic windows where they have like these divided muntins, and you have these kind of little pieces of glass. So our flagship technology doesn't work because it needs to attach directly on the glass, but our secondary product works on that because it sits behind the window. So we have these kind of complementing solutions that in most cases, if one doesn't work, the other would work. Sometimes operable windows or sliding doors become a challenge. So we have, one solution works on them, the other doesn't, and we'll have to work around that. At the same time, if you look at houses, so the housing market, there are other solutions there that would be probably as cost effective as retrofits, because these are very, very small windows. There's a lot of replacement windows now manufactured at overseas, coming to the US at very, very low cost. And typically houses have lower window to wall ratio, lower window to area ratio. So you have very few windows basically to retrofit or even replace if you need to. But certain houses can be a good fit for our solutions. They have like large glass areas. Either one of our systems would work on these kind of houses or types of windows.
So can you tell us a bit more about your competition today? Do you have any direct competitors doing the same in the US or in the rest of the world? How are you guys different and differentiate yourself? I mean, how do you compare yourself to other solutions in the market, and how do you protect that technology from cheap window manufacturer abroad that would like take a sample of yours and try to replicate that at a lower cost?
Yeah, so there's a lot of window retrofit kind of low-cost window retrofit products now available. However, majority of them are like either storm windows or storm windows that are exterior or interior, and these are more suitable for houses. That's what I said. Like basically, you have these kind of cost-effective solutions that are available. It's called a storm window because it's meant to really protect the existing windows during certain conditions like a storm or hurricane, but at the same time it adds a little bit of an insulating value to it. And now there's like a little bit of advanced storm windows that have like low efficiency, low emissivity coatings on the glass, or that kind of turn single pane to double pane, but they're screwed into this, the building, the facade, or the kind of the walls, and they're not suitable for high-rise buildings, very low-rise, 1 or 2 story kind of historic building or houses mainly. On the interior side, there are secondary windows that are now, this is like a new category that is gaining traction, which is basically a window that sits behind the existing window. So that's our secondary product, fits under that kind of category. Our primary product, the insulating glass retrofits, is kind of the only technology that can be installed on the exterior of building facades, and basically adaptable to commercial buildings, high-rise buildings, low-rise buildings, all kinds of windows and facade systems. And it can also be installed on the interior. It's the only technology that creates a hermetically sealed desiccated thermal cavity between the existing glass and the new glass, so it makes it perform like a factory-made insulating glass unit. So in terms of condensation resistance and things like that. So when you have certain glass technologies like smart glass technologies, transparent photovoltaic, they cannot be installed behind. Otherwise, you either lose 50% of the power conversion efficiency, or you create other problems with thermal stress, with tinted windows behind existing glass. So they need to be the first layer. So that's kind of a unique competitive advantage to us in terms of having an exterior non-invasive retrofit solution, retrofit technology. At the same time, even our secondary retrofit product is unique because it's breathable, and we've created this passive venting mechanism to it that allows the system to breathe, to kind of let the excessive heat build up in the air cavity to expand and go outside and get outside the window if needed, so that it doesn't really build excessive heat in the cavity that could cause thermal stress on the existing glass, or excessive or persistent condensation, for example, unlike any other secondary window retrofit product. So both products, we have patents filed on them. We have 5 patents received in the US and Canada, pending patents in Europe, patents issued in China. So we have a big IP portfolio. We have a lot of trade secrets, basically proprietary components that are parts of our trade secrets portfolio. So those creates another competitive advantage and a high barrier to entry that helps us maintain this kind of competitive edge in the market, that if someone else wants to copy the product, it's not that easy. It requires a lot of R&D testing in the beginning to get it right, to get the formula right for these different materials. To give you an example, just one test takes about 4 months, the accelerated weathering tests, to simulate like a 20-year performance. And at the same time, there is an important point, especially with our flagship technologies, that requires the expertise and equipment of different industry players. So you have glass manufacturers, typically they don't fabricate or manufacture metal window systems, and metal window systems, they don't have manufacture glass. So having the insulating glass kind of expertise is not available at the metal window manufacturers, and vice versa. The CNC equipment and the machining expertise is not available at the traditional glass manufacturers. So they buy from each other. Basically, the glazing contractors are the aggregators that compile and kind of fabricate everything together. So we need all of those, and very, very few companies have the expertise and equipment of and they sell their own glass and they sell their own facade and metal window systems. So that's another layer of protection. And as I said, the R&D testing, you have like many years, and that's added cost. So it's much easier for larger companies just to basically license the technology if they're interested in offering this to their clients, or getting into the retrofit market, which is becoming a massive market compared to new construction.
So finally, looking a little bit at the market opportunity here, I mean, where are you guys at today in terms of like actual project that you're working on? And what's the potential that you see in the US? What are the next steps to scale your operation? I mean, we were covering a little bit about, the logistics and training like the installers and making sure that the local glass manufacturer and were able to give you the production that you need. So how do you see those paths? What needs to happen for you guys to go to the next level in terms of market penetration?
Sure. So right now we're at that position. We're transitioning from, let's say, the pilot slash demonstration phase to an actual commercialization phase where we're doing actual full projects. The past couple of years, we've done small scale installations, retrofit projects like a floor in a building or a small two-story high-rise, low-rise building, and that was very important, necessary, and helpful, basically, in understanding the performance of the product in different climate zones, different kind of geographic locations, and understanding exactly the value proposition, the cost benefit, and where would make more sense than other locations. We've done projects in, or installations in Boston, Seattle, Los Angeles, Portland, Oregon, New York, Minnesota, Twin Cities. So Houston also. So we've done now we have a really good understanding of where it's best in terms of market penetration, where it makes more sense in terms of energy savings, what kind of building types, building locations, characteristics, all of that. And right now we have several big projects in our pipeline that we're working on, 10-story to 50 stories, basically, to do retrofits. And you have, for both products, basically, for both solutions, we have these kind of potential projects now. For us, for the next step, we have, with the way we built our business model is that it's easily scalable. It's not capital intensive. A lot of people think that this is a deep tech or hard tech, and there's a hardware product involved. So it's very capital intensive. It's really not, because we're outsourcing all of the capital intensive parts to partners. So we don't have our own manufacturing facility. We don't have, equipment, labor, or anything. It's outsourced to partners. We have a really great partner here in Houston who can support up to 200,000 or more square feet produced per year. So that's a big volume. And then we have another partner lined up, basically, if we need more capacity beyond the capacity of our existing partner. In terms of training installers, yes, training sometimes required in our flagship technology. The other technology is very simple. It's kind of DIY. Even facility engineers or facility people can do the install. It doesn't require skilled labor. But for our flagship technology, it's not like it's rocket science. So it's kind of easy to install. At the end of the day, training on a couple windows after they install. So to give you an example, we did training for a group one time, and it took them 1 hour to install the first window, half an hour to install the second one, and then 10 or 15 minutes to install the third one. So that gives you an idea of how the progress can happen really fast in terms of learning how to do this system or this retrofit. So everywhere we go, there are glaziers that are local that are interested in the retrofit market for a number of reasons, and they would like to kind of learn a new system, new technology, and have competitive edge in the market to do these type of projects. So we've trained several partners, and as we go through this process, we improve our training program, make it more efficient, more cost effective, more faster. So we believe now we're at the point where we're ready to kind of transition to a full commercialization for our solutions.
And just Based on your estimates and the different like suitability in terms of like region and type of buildings and climate in itself, what's your estimate of the amount of like buildings or square footage or market size in itself, to give a little bit that overview on the US side only, maybe?
Yeah, I mean, as if you remember, we've done some research, and based on estimates, we think there is like globally 292 billion square feet of single pane windows available. That's the existing kind of base of installed windows. If you run you do the math, that's about like a $9.5 trillion retrofit opportunity in general for window retrofits globally. Now, in the US, there are estimates that show about 7 billion square feet for single pane windows. You're talking 20 billion square feet for energy inefficient windows, which include low performing double pane and single pane. And that's in terms of a market opportunity, we're talking about, if I'm not mistaken, I think around $200 billion market opportunity in general. Every year you have 1 to 2% retrofit rate in general, renovation rate. Let's say there's new construction that happens at 2.5% of the total built environment, or like all existing buildings, 2.5% retrofit renovations, and then I think 0.5% demolished, buildings demolished. So that 2.5% renovation, the estimate is that 1% of those buildings basically do replacement windows. So that's the market for replacement. That's estimated at about, if I'm not mistaken, I think I remember the math, it was around $150 billion per year. And if you take that and you focus on a subsegment of that, that's like commercial buildings built between, let's say 1950 and 2000, and only single pane, you're talking about $30 billion market opportunity in the US annually. And then for us, if you dig deeper, we focus on these niche markets. It's, you have more than $1 billion in terms of market opportunity for Inovues in terms of the serviceable obtainable market. So it's a huge market, and that's not factoring in kind of international market for Inovues. So if you look at that, that's obviously bigger, and there is licensing plays that could be adopted here with the international market. So, and the reason is because basically you have multiple drivers for retrofits. It's not all the time just purely driven by energy efficiency. You have thermal comfort, or comfort being a major driver, acoustic comfort, acoustic insulation. You have aesthetics, so upgrading, refreshing the look of the building to help reposition it in the market following a deep energy retrofit, for example. So there are many drivers for retrofits, for adopting our technologies and solutions. So if you factor all of that in with the different markets, hotels, commercial office, multifamily residential, hospitality, higher ed, schools, you see that there's a huge market opportunity that is largely untapped right now, because full replacement just doesn't make financial sense. And now is the perfect time with all these kind of incentives, tax deductions, tax credits that are available in the US and abroad. So.
Okay, so finally, what's I would say, what's your personal opinion on the climate crisis? I mean, something that I always ask to my guests on the show. Try to understand, what would you say to people who feel demoralized by all the already visible consequences of climate change? I mean, are we doomed?
I don't think we're doomed. I think from where I'm sitting, I'm seeing a lot of efforts, a lot of movements, and a lot of companies are taking action. Obviously, more is needed, and more is better here, not less is more in this regard. But I'm an optimistic person, and I believe we'll be able to get to where we need to be at net zero, keep it under 2 degrees or 2.5 degree 1.5 degrees on time by 2030, 2040, with the efforts that is being made. Obviously, there's a lot of efforts in the works right now, government, public, private sectors taking a lot of really interesting initiatives, either fostering and incubating new technologies or encouraging the development of new technologies that will get us there. And there's right now technologies already available that can get us there. So these kind of regulations and incentives is really playing a major role. And if you ask me, we need to have those in every jurisdiction, every city, if we want to really catalyze change and make it happen on time and fast enough. Incentives alone are not enough, and leaving it to the private sector is not enough. All of these at play form really strong tailwinds to be able to make that happen. You have the kind of sustainability targets for corporates and the private sector with ESG, basically the environmental targets for net zero carbon neutrality. That's really helpful because the private sector is pushing. When you have building owners and their clients are asking that I cannot be in an energy inefficient building, and they move to different and more energy efficient, that's pushing the market to really adopt and improve the performance of their existing structures. So I don't think we're doomed. I think there's a big movement happening. Not a lot of people are hearing about it because it's happening in certain segments in the market. But I think over the next 5 years, it's becoming more mainstream, and there's signs that adoption is rising for these kind of technologies, and we're creating the right environment for it to reach the goal of net zero or carbon neutrality by 2030 or 2040. So and it's interesting, when I started Inovues, I heard a lot about the climate crisis, but I didn't dig deep into the science and learning more about the kind of the problem specifically and doing research about it. So the first part of my market research and analysis was just to learn more about that problem. And in our early market research book, we have like 20 pages just talking about that climate crisis and exactly showing why buildings are sort of like a big important piece of that puzzle to solve, and how everything is kind of lined up together, from how things are working and over the history, how things evolved to where we are, and how basically humans have contributed to that rise and the climate change and climate crisis. And the science is there, the numbers are there, and anyone can really look for them and see how we can basically, if we start to implement certain solutions, you'll see the impact, and it's already being now monitored, and you can see the impact. The line on the charts is improving. So I think we have what it needs, what it takes to get there. We just need to kind of keep building the momentum around this movement and support new technologies, support new initiatives, and take a holistic approach with incentives, regulations, and public-private sector working together to make it happen. So,
how can the listeners of the show, founders, investors, experts, can help you?
Spreading the word, spreading the message. Basically, a lot of building owners, a lot of people don't know that our solution exists, or there is a solution for the building envelope part, or the building efficiency problem. And a lot of what we're doing is educating the kind of commercial real estate market that there's now cost-effective solutions that can be considered like an energy retrofit for facades and windows, and it's really cost-effective, and it makes sense to happen even before upgrading the HVAC systems and heating cooling systems, because then you can downsize those systems, you can save on the upgrade costs, and be able to even transition to electric heat pumps or electrify the building. In terms of investors, obviously, startups needs funding, and we're on the journey to kind of get to full commercialization. So we're raising funding all the time, basically, and we're about to launch Series A soon. So we're looking for investors who are interested in our venture in climate tech and deep tech, and helping us get to market faster and bring this technology to building owners.
But thank you so much, Anas, for your time, for all the incredible insights, for all the effort and what you guys are building to make this world a better world. So thank you so much for coming on the show.
Thank you, Guillaume. It's great chatting with you, and really appreciate having you on the podcast.
Thanks again for joining us on the Tech for Climate podcast. I hope you enjoyed the show. Stay tuned next week for more climate tech insights. In the meantime, head on over to our webpage at startupbasecamp.org, where we have lots more insights and resources for anyone wanting to get involved in climate tech. If you find our resources useful, please consider donating to support our small self-funded team. Don't forget to subscribe and share with your friends, and see you next time.